L is what? Same. But if you look at the second moment of area, which has lower? Yeah. So i.e. buckling, so from the second moment of area, IZZ is less than what? IXX. So therefore, buckling will occur about the what? ZZ axis. Yes. Hello.
It's not working at separate levels.
Oh, okay.
So if you could just
Hello. Oh yeah, I'm pretty loud down here. Hello. Thank you. Yeah. Thank you so much. Thank you. Okay. You want me to sing a song? No, I'm just kidding. I'm just kidding. Okay. All right. So we now. This might be pretty new to you. This is where we do what? Analysis. Are we clear? Okay, this is where we carry out what? Analysis now. Okay. So from here, we know that we have to use this formula over here, right? So what we don't know, so coming back to this formula now, okay? What we don't know is we don't know what is our P over A. We have not a clue about our P over A yet. Okay, now P over A we can get from the what? Chart. Okay, we have, so now before we go on, let's go back to the chart now. Okay, let's go back to the chart. So to use this chart, right? To use this chart, what we want to determine is the response. The vertical axis is the what? The response. Okay. So in order to use this, we have to determine two values. Okay. In order to use this chart, we have to determine two values. Before we use this chart, there will always have information regarding. So in your term test, I might give you 4 different charts. You can use the wrong one. Okay. How do you know you're using the right one is dependent on what? Young's modulus and its what? Use strength. Are we clear? Okay. So in order to use this chart, we need to determine two values. These two values we have to determine is LE over R and what? EC over what? R squared. Right? And we have to be very cautious down here. I'll tell you what we have to be cautious about shortly. Right. So from here, from the chart, yes, it's okay.
Yeah. You're done.
Yep.
Just hold this down to turn off.
Okay.
The light will,
I will.
and then turn it back on. You just hold that.
Yeah, I'll tell the next instructor.
Yeah, and then as for that, you don't need to touch it.
We don't touch it. Okay.
Yeah.
Okay.
Okay.
Thank you so much. Right. So from the chart, okay, to determine P over A, right, we need to calculate our LE over R and EC over what? R squared. Okay. So LE, Eugene softer. LE we know already. Okay, LE we know already. So next we have to determine our R. So from here we are going to find our RZ. So RZ, if we go back to our table, right, from here, RZ is equal to what? Can you all see here? And this is in what? Millimeters. RZ is equal to 34.8 times 10 to power minus 3 meters. Do everything in meters, okay? So we know our RZ. Our E is equal to what? 12 millimeters. So this is given in the question. The next thing we have to be careful, where a lot of students, including myself, we will make mistake, is this C value. Okay, what is this C value? Okay, so coming back to here, right? The axis of interest is what? The axis of interest is this axis over here. So I'm going to highlight this axis. So the axis of interest is this axis over here. Yes? So what we have to be looking at is the distance furthest away from the green axis. I repeat again, C is the distance furthest how to spell furthest, anyone? F-U-R. Thank you. Furthest, the distance furthest away from the where? From the centroid. So for this case, it is this value over here. So BF is what? 0.148. So C is equal to 0.148 divided by 2 is equal to 0.148 divided by 2 is 74 times 10 to the power minus 3 meters. So now we have everything now. We can calculate our LE over R. Okay, so LE over R. So our LE is 3.8. Now remember to convert all this into meters, okay? 34.8 times 10 to the power minus 3. So 3.8 divided by 34. 3.8 divided by 34.8 power minus 3 is equal to 109.2. Okay, 109.2. And then the next one is EC over R squared. So E over here is 12 millimeters. C we calculated to be equal to what? Can't remember. 74 times 10 to the power minus 3. And then R squared is equal to 34.8 times 10 to the power minus 3 squared. So this will be equal to 12 power minus 3 times by 74 power minus 3 divided by 34.8 power minus 3 squared. So this will be equal to 0.733. When doing this calculation, make sure that your calculator is in radians mode. I'm just kidding. Okay, that's not matter. Okay, there's no sine or cosine, so don't calculate. Right. So now with these two values, we are now going to use this graph now. Okay. So 109, so LE over R is 109.2. So if this question does come out in this form, you have to do this. Okay, you have to draw a straight line and just eyeball. Okay, so eyeball, so this 125, okay, 120, 110. Okay, I'm going to eyeball this as 110. So this will be our 109.2. Now EC over R is equal to what? 0.733. So do we have 0.733? Anyone? No, right? So you can just do this, okay? So we know that this is 0.6, this is 0.7, 0.733. I'm just going to approximately over here. I mean, not exactly halfway, maybe somewhere around here. So where it intersect, this is your P over A. So P over A is equal to 90 times 10 to the power 6 Pascal. Okay. So in your term test, you have to label all this. Are we clear? Okay, you have to label all this. Okay. Every student will have a different answer because you eyeball differently. Okay, don't worry. Okay, my Excel spreadsheet will be able to manage the different eyeballing. Okay. So from here, from the chart, we know that TCR over A is equal to 90 times 10 to the power 6 Pascal. Okay. So the factor of safety is equal to 90 times 10 to the power 6 divide. So the load that we are carrying is 175 times 10 to the power 3. The cross-sectional area, go back to our table, the cross-sectional area is equal to what? 5700. Okay, so it's 5700 times 10 to the power minus 6. So this will be equal to 90 power 6 divided by 175 power of 3 divided by 5700 power minus 6 is equal to 175 power 3 divided by 5700 power minus 6. And then it's 90 power of 6 divided by this is equal to 2.93. Are we clear? Okay. Any questions? Yes. Either way. If I don't give, you have to use a full-blown formula. If I give, you just use this. No. The formula, the full form of the formula means you have to calculate from here. Yep. Then you calculate your stress max. Okay. Then stress max, you also have to calculate your stress yield. You given your stress yield. Okay. Listen. If I don't give you the chart, you use the formula. That's all you have to remember. Any questions so far? No? Yes. Usually you do. Okay. And I'll tell you. Okay. If I want you all to calculate both axes, I will tell you all to determine both axes. Are we clear? Okay. Yes. Yep. Yep. And this is very significantly lower. Yes. No, does not matter. Why? Why I do this so that you all can recognize the curvature. Only for that reason, okay? Only for that reason. It do left, it do right, does not matter at all. It's going to be the same. Any other question? No, I'll let you guys go. And then on Friday, there's another way to determine centric buckling based on a different technique. And I'll teach you on Friday.